This lesson is Simplifying Radicals Part 2. Yesterday we worked on simplifying a radical such as the square root of 50, and we saw that if we could rewrite the radicand or 50 as the product of two numbers, such as 25 times 2, where one of those is a perfect square, we then would take the square root of 25 out from under the radical as a 5, and we would be left with 5 to the square root of 2. Okay, so today we're going to look at some more rules of radicals, and we're going to start with adding and subtracting. So when you're adding or subtracting radicals, you treat the radical as if it were a variable. And remember that you can only add or subtract like terms. So if we have 5x plus 3x, we add the 5 and the 3 and we get 8x because those are like terms. Likewise, negative 6 plus a 3x is equal to negative 3x. Now in the third one here, we have 2x minus 4x, those are like terms, plus a 4y. Well, the y and the x are different terms, they're not like terms, so we can't add those, but you can combine 2x and negative 4x and get negative 2x, and then it's just negative 2x plus 4y, because you can't combine those, so that's your final answer. So likewise is how we work with radicals. So if you look at this problem here, 5 to the square root of 2 plus 3 to the square root of 2. Or you can say 5 times the square root of 2 plus 3 times the square root of 2. You add the coefficients and you get 8 square root of 2. Just like the problem ahead. Okay, and then you have 3 times the square root of 2 minus 6 times the square root of 2. The square roots are like terms, so you're just going to work with the coefficients. 3 minus 6 is negative 3, and so your final answer is negative 3 times the square root of 2. Like terms, again, have to be present to combine them. So when you have 4 square root of 2 plus 4 square root of 3, the radicals are not like terms, so there's nothing you can do there. You just leave them alone and you can't simplify it any further. But sometimes you're going to get something like this one. 5 to the square root of 2 plus 4 to the square root of 32. Well, immediately the square root of 2 and the square root of 32 are not like terms. However, this can be simplified. So we have 5 to the square root of 2 plus, and I rewrote the square root of 32 as the product of 16 times 2. Well, we know that the square root of 16 is 4, so we're going to take that out from under the radical, and you're left with 5 to the square root of 2 plus 4 times 4 to the square root of 2. And then we get 5 square root of 2 plus we multiply 4 times 4, and we get 16 square root of 2. Now we have like terms. 5 to the square root of 2 plus 16 square root of 2, and you just add the 5 and the 16, and you get 21 square roots of 2. So sometimes it's not obvious that they're like terms. If there's any simplifying that can be done, you need to simplify first and then see if you can combine. Okay, so that's adding and subtracting. Now let's move on to multiplying. Multiplying coefficients of radicals, you multiply the coefficients, the ones that are outside the radical symbol, first, and then you're going to multiply the radicands, or what's under the radical symbol, second, and then if possible, you're going to simplify. If there is no coefficient in front of your radical, in other words, if you have the square root of 6, there's an understood 1 right there, okay? So let's look at an example. 5 times the square root of 2 times 7 times the square root of 3. So you multiply the 5 times the 7, and that's 35. And then you multiply the 2 and the 3, which is under the radical, and that stays under a radical, and it's 35 times the square root of 6. And then you're done. Now in this next one, we do the same thing. We're going to multiply the 6 times the 3, and that's 18. But when we multiply the under the radical, the square root of 6 times the square root of 4, 6 times 4 is 24. So we have now 18 times the square root of 24. But the square root of 24 can be rewritten. The square root of 24 is rewritten as 4 times 6 because the square root of 4 is 2. So I take that out from under the radical, and you get 18 times 2 times the square root of 6. Okay? The rules are real important, and you can refer back to this when you start trying to simplify. Now, I believe this is one of the most important things here for you to remember. This part right here. This is something that you will see a lot, okay? And what we're going to do next. You are going to need to understand that any radical multiplied by itself is the number that was under the radical. In other words, when you multiply 2 times 2 and get 4, the square root of 4 would be 2. So here, the square root of 3 times the square root of 3, let me say it this way. You could rewrite the square root of 3 times the square root of 3 as the square root of 9, and the square root of 9 is 3. Okay, if you just follow the rules we were saying before. You have the square root of 6 times the square root of 6. Well, that would be the square root of 36, which is 6. So the square root of anything times itself is the number itself without the radical. The square root of 83 times the square root of 83 is 83. Okay, so hopefully you can remember that because you're going to need that one. All right, let's look at this next one. 4 square root of 3 times 5 square root of 3. So again, just follow the rules. You're going to multiply the 4 times the 5, and then the square root of 3 times the square root of 3 is 3. So you're left with 4 times 5, which is 20, times 3, which is 60. Okay, so those are the rules of multiplying. Next is dividing. I think we looked at one of these yesterday, but let's look at another one. When you have division with radicals, you can rewrite it a couple different ways, and you're going to do what's best for you. When I see the square root of 50 divided by the square root of 2, well, I know that 50 divided by 2 is 25, and I can take the square root of 25. So in this case, it's helpful to rewrite the square root of 50 divided by the square root of 2 as the square root of 50 divided by 2, and you can do that. And then 50 divided by 2 is 25, and your answer is 5. You can also go the opposite way. In this next one, I have 16 divided by, that says, this I think should say, sorry, that's a mistake. It should say the square root of 16 divided by 4. And actually, that's probably not a good example because 16 divided by 4 is 4. So we don't have to do this. But so yes, you could just change that to the square root of 4, which is 2. But you can rewrite it as the square root of 16 divided by the square root of 4, and you'll get the same answer. But anytime you have, see if I can make another one. If you have a let's try that. Okay. No, that's still going to be the square root of 3. Anyway, just follow the rules. If it makes sense to switch it up and write it the other way, you can. I can't think of a good example off the top of my head. Let's go to the last part here. Rationalizing the denominator. Okay, rationalizing the denominator is the name of what we're going to do. The main thing is in geometry or in any math, you can never leave a radical in the denominator, ever. Every teacher is going to mark it wrong. It's just, you can't do it. So you might get an answer that looks like this. 5 divided by the square root of 2. That may well be the correct answer, but you cannot leave it that way. So what do we do? Okay? So we want to change it so that's not there. Well, the first thing to remember is that if 5 divided by the square root of 2 is our correct answer, well, we can't change our answer. So what do? Well, you can multiply anything by 1, and that doesn't change your answer. So we're going to have to think about that. Now think about anything divided by itself is 1. 5 divided by 5 is 1. 20 divided by 20 is 1. So the square root of 2 divided by the square root of 2 is 1. So anything divided by itself is 1. And then if you go back to multiplying, we said the square root of 2 times the square root of 2 is 2. So anytime you have a radical in your denominator, If you multiply that by itself, you'll get rid of it. However, you can't change the value. So what you do is we're going to multiply, we have 5 divided by the square root of 2. We're going to multiply that by the square root of 2 over the square root of 2, because that is 1. We're not changing our answer, but we get rid of the radical. So in the top, you just get 5 times the square root of 2, and in the bottom you get 2. This then becomes your answer. So all we did is we just changed 5 divided by the square root of 2 and got rid of the radical in the denominator. Let's look at another one. Okay, 12 divided by the square root of 3. Again, we want to get rid of that square root of 3 in the bottom. So we're going to multiply by the square root of 3 over the square root of 3, because that's 1 and it doesn't change our answer. Well, then we get, I'm going to write it here, we end up with 12 square root of 3 over 3. So that is fine. However, we can still simplify one step further, because we know that 12 divided by 3 is 4. And so your final answer will look like this. Okay, so I'm going to give you some problems to practice, and I'm also going to put a video on here from YouTube that if you need additional examples. Thank you.